Hello student, I am going to continue from the last video. We are discussing about sampling. So next slide is the sampling process comprises several stages. Like first you need to define the population of concern, then you need to define the sampling frame or set of items or events possible to measure, specifying a sampling method for selecting items or events from the frame. Then after that we need to determine the sample size. After that we have to implement the sampling plan. Then we will go for data collecting, and then after that we need to review our sampling process. So population definition is that population from which the sample is drawn may not be the same as the population about which we certainly or actually want information. Often there is large but not complete overlap between these two groups due to frame issues, etc. Means there should not be a overlap or complete overlap between these two groups, between sample and population. So there might be overlap due to the frame issues between the samples, but there should not be a complete overlap. And sometimes your whole population might be very small. In that case you need to take out all the population as a sample, or might be your sample might be of different thing but your study might be on different thing. So the studying on the sample might be put some understanding on the different population. Like here you can see, for instance, we might study rats in order to get a better understand of human health, or we might study records from people born in 2008 in order to make predictions about people born in 2009. So those samples and actual populations might be different. So what is sampling frame? It is most straightforward case such as the sentencing of a batch of material from production. It is possible to identify and measure every single item in the population and include any one of them in our sample. However, in the more general case, this is not possible, because if the population is larger, we cannot measure every single one item to be included in our sample. So there is, however, there is no way to identify all rats in the set of all rats. Where voting is not compulsory, there is no way to identify which people will actually vote at a forthcoming election. So there are problems in counting or in analyzing every sample in a population. So we need to go for a sampling frame. As a remedy, we seek a sampling frame which has the property that we can identify every single element and include in our sample. The sampling frame must be representative of the population. So first type is probability sampling. A probability sampling scheme is one in which every unit in the population has a chance. So we'll try to understand during probability sampling which items in a sample or in a population has a chance, means has a value greater than 0. That scheme is in which every unit in the population at least has a chance or chance of probability of being happening, means greater than 0% of being selected in the sample, and this probability can be accurately determined, and you can determine this probability accurately. When every element in the population does have the same probability of selection, this is known as equal probability of selection. So what is EPS? EPS means equal probability of selection. When every element in the population have the same probability of selection, this is known as equal probability of selection design. Such designs are also referred to as self-weighting because all sample units are given the same weight. So here you can see, if we can sample by selecting items from the population having equal probability of selection, then we can say that that sample is self-weighting because all the sample in that all the units in that sample are given the same weightage because we are selecting those items from the population giving or having equal probability of happening. So in case of probability sampling, there are various types. Like probability sampling includes simple random sampling, systematic sampling, stratified random sampling, cluster sampling, multi-stage sampling, multi-phase sampling. So there is also one point, that is about non-probability sampling. Any sampling method where some elements of population have no chance of selection, there might be. These are sometimes referred to as out of average or undercovered. Means those elements might not have any chance of selection belonging to the population. So in general case of probability sampling, we cannot select that item, or where the probability of selection cannot be accurately determined. So probability of selection cannot be determined, or we cannot choose those item to be included in the sample because it does not have the chance of happening, no chance of selection. It involves, in non-probability sampling, it involves the selection of element based on assumptions regarding the population of interest, which forms the criteria for selection. So here, when we try to deal with non-probability based sampling, we try to think about a criteria depending upon which we will go for selection. Here we are not going for probability measure. Hence, because the selection of elements is non-random, in this case of non-probability sampling, the selection of elements is non-random. Non-probability sampling not allows the estimation of sampling errors. So in case of non-probability sampling, we cannot estimate the sampling errors, or we are not allowed to do that because it does not follow a probability based measurement, but it follows a criteria based selection. Example is like, we visit every household in a given street and interview the first person to answer the door. In any household with more than one accountant or occupant, this is a non-probability sample because some people are more likely to answer the door. Example, an unemployed person who spends most of their time at the home is more likely to answer than an employed housemaid who might be at work when the interviewer calls. And it's not practical to calculate these probabilities. So this is a scenario where we cannot apply the probability based sampling because we cannot predict, and that does not follow, the sample doesn't follow the probability based sampling because the household with more because some people are more likely to answer the door and some people more likely not to answer the door, and we cannot decide which one will be best using probability sampling. And that is why you cannot go for probability sampling. We have to go for non-probability based sampling, putting some criteria. In non-probability sampling includes accidental sampling, quota sampling, and purposive sampling. In addition, non-response effects may turn any probability design into a non-probability design. It means that if you are trying to handle link sampling and you are trying to apply probability based sampling and you find that non-response effects which may turns up any probability design into a non-probability design. If the characteristics of non-responses are not well understood, so in case of if we try to analyze a item and we cannot find any response, so in that case we cannot find the probability measurement. And also if we don't understand why those items or why we cannot determine or measure the probability, that belongs to non-response. And if we cannot verify that non-response region, since non-response effectively modifies its elements probability of being sampled, obviously that non-response event might effectively modify the occurring that sample or selection of the sample less or modify that probability value of being sampled. So that is why any probability modeling in any probability sampling technique, if the items in the population does not respond, or if we say that it happens to be non-response type, then we cannot go with the probability design. We have to turn that probability design into a non-probability design. So simple random sampling. First we try with simple random sampling. This is applicable when population is small and also homogeneous and readily available. Three characteristics. First, population is small, the item should be homogeneous, and items should be readily available. Then we can go for simple random sampling. All subjects of the frame are given an equal probability. So in that scenario, in that simple random sampling, all the subsets of the frame are given an equal probability. Each element of the frame thus has an equal probability of selection. It provides for greatest number of possible samples. This is done by assigning a number to each unit in the sampling frame. So by applying simple random sampling, it provides for greatest number of possible samples. So this is done by designing a number to each unit in the sampling frame. A table of random number or lottery system is used to determine which units are to be selected. So here the selection mechanism is simple, which is based on a random number or a lottery system is used to determine which units of these populations are to be selected. So in that case we know that, or we can assume that all the units have the same probability to be selected, and that is because all the subsets of the frames are given an equal probability. Each element of the frame thus has an equal probability of selection, and that is the mechanism of simple random sampling. And to do simple random sampling, the population need to be small and homogeneous and readily available. And estimates are easy to calculate. Simple random sampling is always an EPS design. Equal probability what? Equal probability selection. But not all EPS design are simple random sampling. Try to understand that. Not all EPS design are simple random sampling, but simple random sampling are always an EPS design or equal probabilities. sample design. Disadvantage is that if sampling frame large, this method impracticable because it will lead to inefficiency of the process. Minority subgroups of interest in population may not be present in sample in sufficient numbers for study. So suppose in the population there are minority subgroups of interest in population may not be present in sample in sufficient numbers for study. Minority means some anomalies or some subgroups which should have been in the sample while we study may not be included if we go with the simple random sampling, because it goes with simple random, and that is why in that random scenario those minority subgroup of interest in population may not be present in the sample in sufficient manners or in sufficient numbers. So sampling schemes may be without replacement. Without replacement means no element can be selected more than once in the sample. Or with replacement, an element may be appear multiple times in the one sample. So there is two type of sampling schemes may be, that is without replacement, no element can be selected more than once in the sample, or with replacement means one element might be appeared twice or thrice or multiple times in the sample set. For example, if we catch fish, then we measure them and immediately return them to the water before continuing with the sample. This is a WR design because the same fish might become again and again, and because we might end up catching and measuring the same fish more than once. However, if we do not return the fish to the water, if we eat the fish, then this become a without replacement. So that is the scenario of without replacement or with replacement. Next one is systematic sampling. Systematic sampling relies on arranging the target population according to some ordering scheme and then selecting elements at regular intervals through that ordered list. So before applying the systematic sampling, we try to arrange the whole target population according to some ordering scheme. In some order, we arrange the population in some order, then selecting elements in regular intervals through that ordered list. Systematic sampling involves a random start, then process with the selection of every kth element from them onwards. So suppose we start with a random number or random selection initially, or initiation of the process of sampling using systematic sampling, then we try to go for a selection of every kth element from then onwards. In this case, k equal to population size by sample size. Here k will be equal to population size by sample size. It is important that the starting point is not automatically the first in the list, but it is instead randomly chosen from within the first to the kth element in the list. So obviously the first element will belong to the first 1 to kth element in the list. It might be anyone from that list which will be chosen randomly. And a simple example would be select every 10th name from telephone directory. On every 10th sample, also referred to as sampling with a skip of 10. So you can see here, this is a sampling of, suppose example is, we need to sample names in the telephone directory, every 10th name from the telephone directory. So that is why we start with initial name, any initial name or any initial name between 1 to 10, then we skip 10 name after that interval. Using that in every interval we try to skip 10. So we can name it every 10 sample selection, or we can name it sampling with a skip of 10 sample. So here you can see the simple sampling of systematic sampling technique. As described above, systematic sampling is an EPS method because this has equal probability system for every element. Because all elements have the same probability of selection. In the example given 1 in 10, it is not simple random sampling because different subsets of the same size have different selection probabilities. Obviously, if the subset is different, then selection probability will be different. If example the set is 4, 14, 24 like that has a 1 in 10 probability of selection, but the rest 4, 13, 24 has 0 probability of selection. That is the point. Okay. So some advantages of systematic sampling is that sample easy to select, suitable sampling frame can be identified easily, sample evenly spread over entire reference population. Disadvantage is that sample may be biased if hidden predictory or periodicity in people population coincides with that of selection. There might be coincidence with the hidden periodicity in the population. So simple sample may be biased. In that case, difficult to assess precision of estimate from one survey. So in this type of sampling like systematic sampling, it is difficult to assess the precision of your estimation of sampling from only one survey. Next is stratified sampling, where population embraces a number of distinct categories. The frame can be organized into separate strata. Each stratum is then sampled as an independent subpopulation. So here the population is divided in distinct categories. We can say the frame can be organized into separate strata, and every stratum is then sampled as an independent subpopulation. Means different strata might not be dependent, those are independent, and will try to act the sampling technique independently over each subpopulation, out of which individual elements can be randomly selected. So from every strata we'll try to select element or item independently, or you can say randomly. Every unit in a stratum has some chance of being selected. So every stratum, every unit has same chance of being selected. But for different stratum, there is less likely to be same chance of being selected. Using same sampling fraction for all strata ensures proportionate representation in the sample. Here what you can understand is that the sampling fraction or the dividation of sample for all strata ensures proportionate, means the numbers of dividing in different strata, the numbers present in every strata, number of item present in every strata has some proportionate value, and which representation in the sample, which represent in the sample. So adequate representation of minority subgroups of interest can be ensured by stratification. So that is the case here. We can achieve that is adequate representation of minority subgroups of interest can be ensured by stratification and varying sample fraction between strata as required. So stratified sampling, finally, since each stratum is treated as an independent population, different sampling approaches can be applied to different strata. That I have told previously that for every strata we can apply different sampling technique. Drawbacks is that to using stratified sampling, first sampling frame of entire population has to be prepared separately for each stratum. First sampling frame of entire population has to be prepared separately for each stratum. So here drawback is that first one is that for every stratum the sampling frame might be different, or we need to prepare that differently. Second, when examining multiple criteria, stratifying variables may be related to some but not to others, further complicating the design and potentially reducing the utility of the strata. So here you can see when we examine multiple criteria, stratifying variables, those variables or criteria may be related to some, and if they are related but not to others, some are related and some are not related, which will complicate the design and potentially reducing the utility of the strata. Finally, in some cases, such as designs with a large number of strata or those with a specified minimum sample size per group, stratified sampling can potentially require a larger sample than would other methods. So in case of stratified sampling, we need a larger number of samples, otherwise it will not be fruitful. So here you can see, draw a sample from each stratum. Here two stratum is that women and men. So we can choose differently, or we can deploy different sampling technique in different two strata depending upon different techniques. So we'll try to go for the next slides and the techniques of sampling in the upcoming video. Whatever I've discussed in this video, please try to understand, and please try to go to the book also, and please try to go through different examples. If you find it difficult to understand, please let me know. Okay, we'll try to resolve it over Google Meet. Thank you.